Okay, we're going to be covering Chapter 1, which is Module 2. And the first thing that is covered in this chapter is evaluating algebraic expressions. Okay, so what do we mean by evaluating? Well, when you evaluate an algebraic expression, you replace the variables by the numbers that are given to you. So for example, if we have something like this, evaluate x plus y when x equals 37 and y is equal to 29, all you do is replace x by 37, y by 29, and you do the calculation. So this becomes 37 plus 29, which is 66. And you're done. Okay? So that's one example. Let's look at another example. Evaluate 3y. I'm not going to write the word evaluate again. Evaluate 3y when y is equal to 14. Okay, what does 3y mean when we have 3 in front of the y? It actually means 3 multiplied by y. Okay? So I'm going to write it like this, 3 times 14, or I can also write it like this, 3 with the 14 in parentheses means the same thing. And 3 times 14 is 42, and you are done now. So let's look at another problem. So here we have evaluate a over b when a is equal to 63 and b is equal to 9. So a over b is a fraction, or actually a division. So we just write 63 on top, we write 9 on the bottom, and 63 divided by 9 is 7. Let's look at one that's a little bit more involved. So here we have 12m divided by n. And m is equal to 8 and n is equal to 16. So I replace m by 8 and n by 16. So I get 12. Now 12m means 12 multiplied by m, so I need to put the m in parentheses like this and divide that by 16. Okay, so there's a couple ways of doing the calculation. I could do 12 times 8, which is a big number, and then divide it by 16, but I know that 8 goes 2 times into 16, so I can just cross out the 8 and make it a 1, and cross out the 16 and make it a 2, and now I get 12 times 1, which is 12, and at the bottom I just have 2. And 12 divided by 2 is 6. So we are done with that one. Okay, let's look at another example. If I have 10p divided by 9, and p is equal to 40, and q is equal to 25. So this would be 10 times 40 divided by 25. And I can divide both 10 and 25 by 5, so this will give me 2, and this will give me 5. So now I have 2 times 40, which is 80, and I have 5 at the bottom, and 5 goes into 80 16 times. So that is the answer. All right. The next section, that was the first section in Chapter 1. The next section is Section 1.2. And here they talk about real numbers. Now, what do we mean by a real number? Aren't all numbers real? Well, actually, they're not. There's a set of numbers that are called imaginary or complex numbers. And we're not going to cover that in this course, but I just want you to be aware of what that means. A number like this, the square root of -1, is an imaginary number because there is no number that there's no square root that gives you -1 when you multiply it. So why do we even use it? Well, it turns out that there are applications which use imaginary numbers and complex numbers. An imaginary number is part of complex number. But we're not going to cover that. So here, we're just going to talk about real numbers. So first of all, let's look at absolute value. What do we mean by absolute value? Well, absolute value is how far a number is away from 0. And the way we indicate absolute value is by using two lines like this. So, for example, the absolute value of 3 is 3, because 3 is 3 spaces away from 0. And the absolute value of -3, of -3, is also 3, because -3 is also 3 spaces away from 0. If you look at the number line, you would have 0 here, I would have 3 over here, and I would have -3 or -3 over here. And they're equidistant from 0. So that would be how we use absolute value. There are not too many applications, especially in this book, which use absolute value, but it's important that you just know what that stands for. Okay, the next thing we're going to look at is additions of real numbers. So, if we add a real number to another real number, so let's say we add 3 plus 5, we get 8. Okay? And if we add a negative number, 3 plus -8, -5, that is equal to -2. Okay, now why is that? Well, if you look at, if I draw a number line, and this is 0, and 3 would be over here, and then it tells you plus -5. Now, in this case, the plus was really telling you it means the same thing as and. So 3 and -5. -5 tells you in what direction you need to go. And since it's negative, we're going to go 5 spaces in this direction. So that's -5. And we're going to wind up at -2. Because it took 3 spaces to get to 0, and another 2 spaces to get to -2, which totals 5 spaces. Okay? Now, in some situations, you're going to be asked to add a whole bunch of positive and negative numbers. So let's look at how that would work. So here's an example. 15 plus -2 plus 7 plus 14 plus -5 plus -12. Okay, so how do we work with that? Well, the suggestion that I have, which makes it the easiest, is first look at all the numbers that are positive, add those together, and then add all the numbers that are negative, and then combine the two. So for the positive numbers, I have 15 plus 7 plus 14 plus, well, that's it, right? So how much is 15 plus 7 plus 14. That's 22 plus 14, which is 36. And my negative numbers would be negative 2 plus negative 5 plus negative 12. And 2 and 5 is 7, and 12 is 19, therefore it's negative 19. So now I'm just left with a simple calculation of 36 minus 19, which is equal to 17. Okay? Now let's look at subtraction of real numbers. Let's say I have 3 minus 7. This can also be written as 3 plus negative 7. And the principle that I just showed you a little while ago using the number line works here as well. So this is my number line, and I have this as 0. I'm going to put 3 somewhere over here. And then whether it says negative minus 7 or whether it says plus negative 7, it means the same thing. In both cases, it means that you're going to go 7 spaces in the negative direction. The negative direction is to the left. The positive direction is to the right. So I'm going to go 7 spaces in the negative direction. So starting at 3, I'm going to go minus 7. And where do I wind up? I'd wind up at minus 4. Okay? So remember the general principle. General principle here is that when you have subtraction, subtracting a positive number is the same as subtracting a positive number is the same as adding a negative number. So a plus a minus b is equal to a plus minus b. Okay, and that's exactly what I had on top. Let's look at an example that contains quite a bit of positive and negative numbers. So we have as follows. I have 8 minus negative 4 minus 2 minus a negative 4 plus 2. Okay, so what does this mean here? I have a negative outside the parentheses and a negative number inside the parentheses. So there's several different ways you can think of this. You can think of a number that is preceded by a negative as the opposite. So for example, if I have minus a minus 4, what's the opposite of minus 4? The opposite of minus 4 is 4. Okay, so you can think of it that way. And therefore, it changes to a positive. Or you can think of the negative sign in front of parentheses as really being a minus 1, an invisible minus 1. And when you multiply a negative 1 times a negative 4, then this is also equal to a positive 4. And actually I can put the plus sign in front of it. Okay? So now, to compute this equation, what I'm going to do is change wherever I have a negative outside the parentheses and negative in front of the parentheses, I'm going to change it to a positive. So 8 minus a negative 4 becomes 8 plus 4, minus 2 minus a negative 4 again becomes a plus 4, and then my last number is plus 2. Okay, so 8 plus 4 minus 2. So 4 minus 2 is 2, so I can rewrite this as 8 plus 2, because these 2 give me 2, plus 4 plus 2. and that's 8 plus 2 is 10, 4 plus 2 is 6, so that gives me a total of 16. Okay, so that's how you work with numbers where there are negatives outside the parentheses and negatives inside the parentheses. Let's look at, try one more here. So I'm going to write this one, 22 minus a negative 18 plus 7 plus a negative 42 minus 27. Okay, so the two negatives after the 22 make that to be a positive, right? So this becomes 22 plus 18 plus 7. Adding a negative is the same as just subtracting a positive. So I can just rewrite this as minus 42 minus 27. So if I combine all the positives, these three, I get 22 plus 18, which is 40, plus 7 is 47. And here, with these two, I have minus 42 minus 27. That gives me minus 69. And 47 minus 69. Remember, I start at a positive 47, and I go 69 spaces in the negative direction, and that gives me a negative 22. Okay, so let's look at multiplication of real numbers. Now, multiplication of real numbers is easier. That's in section 1.5. It's easier, actually, than addition and subtraction. There's very basic rules that you have to remember. When you multiply a positive number times a positive, the answer is positive. When you multiply a negative number times a negative number, the answer is also positive. However, when you multiply a negative by a positive, that equals a negative, or a positive times a negative, that also gives you a negative. All right? So, if I have 6 times minus 8, that is a positive times a negative, so my answer is going to be negative, and therefore it's going to be equal to negative 48. However, if I multiply a negative 6 times a negative 8, my answer is going to be positive. Now, the rule here is, if you follow the logic, if I have two negatives and I multiply them, I get a positive. What happens if I have 3 negatives? Well, 2 of the negatives are going to give me a positive, and then I multiply by a negative, so the answer is going to be negative. So I can generalize this whole thing to say that an even number of negatives gives me a positive, but an odd number of negatives gives me a negative. All right? Now, some of the additional sections in this chapter should be fairly obvious. So one of them, it says that anything multiplied by 0 is equal to 0. So 3 times 0 is 0. 1024 multiplied by 0 is also equal to 0. All right? Now we're going to look at a little more complex evaluation problem. So let's say I have the following. Evaluate two x squared when x equals 3 and when x equals minus 3, negative 3. So I'm going to do two evaluations, and let's see what the answers are that I get. Okay? So I'm going to replace first x by 3. So this is going to be 2 times 3 squared, which is 2 times 9, which is 18. Okay? Now what happens if I put in negative 3? 2 times negative 3 squared is going to be 2 times minus 3 times minus 3. Two negatives give me a positive, therefore it's 2 times 9, and the answer is also 18. Okay? Now, when you're dealing with negative signs in front of exponents, there is an important principle that I would like to point out. So let's say I have negative 3 squared. By definition, when you square a number, it just means you multiply it by itself. So this is equal to minus 3 times minus 3, which is equal to 9. Two negatives multiplied by each other give you a positive. What happens if I have it written like this? So instead of a parenthesis around the negative 3, I have the negative sign in front of the 3. The rule in terminology, when we write in math, the exponent only applies to whatever number is right next to it. So this squared only applies to the 3. It does not apply to the minus, to the negative sign. Okay? So what this means is minus 3 times 3, which is equal to minus 9, or negative 9. Okay? So remember that. This is an important point. If you don't have the negative sign in a parenthesis, your answer is going to be negative. So let's look at an example where we have to do some calculation. So I'm going to do an evaluation here. Minus 3 to the x to the third power when x is equal to 2 and when x is equal to minus 2, negative 2. So let's see what answers do we get. Alright, so I'm just going to replace x by 2 first. So I get minus 3 times 2 to the third power. So the 3 exponent only applies to the 2. So this is equal to negative 3 times 2 times 2 times 2. 2 times 2 times 2 is 8. 3 times 8 is 24, but I have a negative sign in front of it. So this is going to be negative 24. Okay? Now let's see what happens when I replace x by negative 2. So I'm going to have the same procedure here, but I'm going to put a negative 2 in here. So this is going to be negative 3, that's outside, times negative 2 times negative 2 times negative 2. 3 negatives multiplied by each other give me a negative. So this comes out to be minus 3 times negative 8. 2 times 2 times 2 is 8. An odd number of negatives, when you multiply them, gives you a negative. And therefore now, a negative 3 times a negative 8 is equal to a positive 24. So look what happened. When I replaced the x by 2, I got a negative answer. When I replaced the x by negative 2, I got a positive answer. Okay? So the signs are very important to keep track of. All right, let's look at division, which is section 1.6 in this chapter. So the same rules apply for division as they do for multiplication in terms of signs. So if I'm dividing a positive by a positive, I get a positive. If I divide a positive by a negative, or is equal to a negative, or a negative by a positive, it's also equal to a negative. And two negatives divided by each other give me a positive. Okay, so when the two numbers are both negative, your answer is positive. Okay, another principle I would like to point out in terms of division is how we deal with negative signs for a division or a fraction. So let's say I have minus 2 minus 2/3. I can write this as negative 2 over 3, or I can write it as 2 over negative 3. So in a fraction, which is really another form of division, you can have, as long as you have one negative sign, it doesn't matter where it goes. All three are equal. Now usually for a final answer you want to put the negative in front of the whole fraction. But during the calculations, in between, it doesn't matter where the negative sign goes, because these three are all equivalent. So the general rule, which is usually stated if you look in your book on page 103, it says minus a over b is equal to a over minus b, which is equal to minus, or negative, a over b. Okay, now let's talk about what happens when we're dividing and there is a 0 in one of the numbers. So if I divide a number by 0, so let's say I divide 0 by a number, so 0 divided by 4 is equal to 0. 0 divided by 12 is equal to 0. 0 divided by 1024 is equal to 0. When you divide 0 by any number, your answer is 0. Okay? Now let's look at the reverse. Let's say I ask you, what is 4 divided by 0? The answer is not 0. This is not allowed. Undefined. Okay, why is it undefined? It's not only because mathematicians are perverse, there is a reason for this. So let's look at what happens when we do a division. When I divide 4 by 2, the answer is 2. And if I multiply 2 by 2, I get 4, right? So when I divide 4 by 2, the answer I get is the number that when I multiplied it back by the divisor, I would get 4, right? So let's say I divide 6 by 3, the answer is 2. 2 times 3 is 6, okay? If I divide 9 by 3, my answer is 3, because 3 times 3 is 9. If I divide 0 by 5, the answer is 0, right? Because 5 times 0 is 0. So this works. But look what happens if I try to divide 5 by 0. There's no number I can put in there that will give me 5. If I put in 0, 0 times 0 is not 5, okay? So that's why you cannot divide by 0. two other rules. These are in sections 1.7, and these are the commutative law and the associative law. So the commutative law of addition or multiplication tells you that you can add or multiply two numbers in any order. So in other words, A plus B is equal to B plus A. Right? So let's take an example. 4 plus 3 is 12, and that's the same thing as 3 plus 4. Okay? Same with multiplication. A times B is equal to B times A. You notice, by the way, that I'm using a center dot for multiplication, and usually it's better to not use a little x, because little x for multiplication can be confused with a variable x. So you can either use a center dot or you can use an asterisk. So if I multiply 4 times 3, okay, let me erase this. 4 times 3 is equal to 3 times 4, and those are equal to 12. I made a mistake here. It's not 12 here. This is equal to 7, right? Okay. All right. Now, there is the associative law. The associative law is similar to the commutative law. And basically, it tells you that you can combine three numbers or more in any order. So if I have A plus B plus C, that's equal to A plus B plus C. So that means that I can first add B to C and then add A to it, or I can first add A to B and then add C. And same thing with multiplication. So A times B times C, I can do B times C first and then multiply by A, or I can do A times B and multiply that by C. Okay? So that should be pretty straightforward. However, you also need to realize that when you are doing division or subtraction, those two are not commutative, right? So if I have 6 minus 2, that is not equal to 2 minus 6. Or when I divide 6 by 2, this is not equal to 2 divided by 6, right? So only addition and multiplication are associative. Okay, now let's look at the distributive law. That is on page 112 in your book. And the distributive law says the following. If I have a number outside a group of numbers in parentheses, and it can be 2 or 3 or 4 or 5, then I can multiply the number outside the parentheses by the first number inside the parentheses, and then multiply the number outside the parentheses by the second number inside the parentheses. So this is equal to A times B, and I can write it as AB plus A times C. And the same thing will work if you have a negative, a subtraction inside the parentheses. So this would be A times B minus A times C. All right? So a specific example of that, now usually we don't need to do that if it's just numbers, right? It's not going to really give us anything, but we use this principle when we have variables. So if I have 9 times x plus 5, or let's say x minus 5, I can multiply the 9 by the x and then the 9 by the negative 5. So this will give me 9x minus 9 times 5, which would be 9x minus 45. Right? And let's say I have 3x, and in parentheses I have x minus 2. So I can multiply the 3x by the x, and then the 3x by the minus 2. So this would be 3x times x is 3x squared. 3x times minus 2 is minus 6x. Okay? So this is called the distributive property. Officially, we call it the distributive property of multiplication over addition or over subtraction. Now, let's look at it, the distributive property, but this time we're going to do it in reverse. So, let's say I have 2x plus 4. And I want to write it as something outside the parentheses times two things inside the parentheses. Well, if you remember, a times b plus c is equal to ab plus ac. I need to figure, if I'm going to go in reverse, I need to figure out what this a is, which is the common factor. Well, if I look at this, I can break it up into 2x plus 2 times 2. So my common factor is 2. And therefore I can take the 2 and put it outside the parentheses. So now I have 2 times x plus 2. And to check whether you did it correctly, you just multiply it out and see if you get 2x plus 4. And 2 times x is 2x, and 2 times 2 is 4, and therefore I did it correctly. Okay? So let's look at a couple other examples here. So let's say I have 6x plus 4. What is my common factor of the 6x and the 4? Well, if I want to break it down, I see that it's 2, isn't it? So it's 2 times 3x plus 2 times 2. And therefore, 2 is my a in this case, just like it was in the previous problem. So the answer is 2 times 3x plus 2. After doing these for a while, then you don't have to do this intermediate step. It becomes fairly obvious. Let's do another one. 9x minus 9. Okay, so I can rewrite this as 9 times x minus 9 times 1. Right? Because if I want to be able to get something out, I've got to have something that remains after I take the second 9 out. So 9 is my common factor, and therefore this becomes 9 times x minus 1. Let's look at one that's got some exponents in it. It's a little bit more complex. So I'm going to write 3x squared minus 9x. And now, what is my common factor of the two groups? Well, 3 goes into 3, 3 goes into 9, x goes into x squared, and x goes into 9x. Therefore, 3x is my common factor, because I could rewrite this as 3x times x minus 3 times 3x times 3, right? So 3x is my common factor, and therefore this is equal to 3x times x minus 3. Okay, that covers section 1 233.7 in Chapter 1. So now we're going to look at the next module, the next section, which is section 1.8. And that is, the topic of that is simplifying expressions. All right? So, let's look at something like this. Let's say I have a minus 3 plus x. Now, when it tells you simplify, what they mean is take out the parentheses. Okay? So in this case, that negative outside affects the numbers inside. So you can think of it two ways. You can think of it as having a minus 1 in front, an invisible 1, and you multiply the minus 1 by 3 and the minus 1 by x. Or you can think of it as the opposite of 3 and the opposite of x. In either case, that will come out to be minus 3 minus x. I'm sorry, there is no x here. So this would be minus 3 minus x. Okay? Let's look at another example. Minus 2x minus 3. So in this case, again, if you think of it as having an invisible 1, minus 1 times 2x is minus 2x, and minus 1 times minus 3 is a positive 3. Okay? So if you have a negative sign outside the parentheses, it will change. If both of the terms inside the parentheses are positive, it will make them both negative. But if one of them is a negative, it will make that one positive. All right? Let's look at one that's a little bit more involved. So I have minus x, minus in parentheses x, minus 2y plus 5. All right? So the negative outside will affect the first one, will make it negative. A negative times a negative for the second one will be a positive, so that will become plus 2y. And negative times a plus 5 will become a negative 5. All right? So there's one more topic left, and that is order of operations. So let's look at the rules for order of operations. So the rules are PEMDAS. Okay, so P stands for parentheses. It can also stand for any grouping symbols. So we do parentheses or grouping symbols first, exponents, then we do multiplication and division from left to right, and addition and subtraction from left to right. The important point here is that you don't always do multiplication before division. If multiplication appears first going from left to right, you do that first. But if division appears first from left to right, you do the division first. Okay? And then you do the addition and subtraction from left to right, although that is really doesn't really matter, you'll see when you actually get real numbers. So let's look at something like this. Negative 2 to the 4th plus 51 times 4 minus 37 plus 23 times 2. Okay? So I'm going to follow the rules that it says here. First thing I'm going to do is look at parentheses. But even within the parentheses, I have two operations. So you can have parentheses within parentheses, or you can have parentheses within brackets. So you can have multiple grouping symbols. So you do the innermost first. Anyway, so here I have an addition and I have a multiplication. So I'm going to do my multiplication first because that's the rule, all right? So this becomes 37 plus 23 times 2 is 46. And this whole thing becomes 37 plus 46 is 83. Right? So now I have minus 2 to the fourth plus 51 times 4 minus 83. Okay, so next I do the exponent. Now remember, the negative sign is outside the 2, so I don't take that to the fourth power, I only take 2 to the fourth power. So 2 times 2 times 2 is 16, right? So this becomes minus 16. Then we have 51 times 4. 51 times 4 is 204. And then I bring down the 83. And then if you have 16, and then you add 204, and you subtract 83, you're going to get 105. And that's the final answer. Okay? So, let me do one more of these. Let's say I have a 4 to the third power plus 10 times 20 plus 8 squared minus 23. Okay? So I have no parentheses here, so I'm going to do the exponents first. 4 times 4 times 4 is 64. And then I'm going to leave the 10 by 20 for a little while. And then I'm going to do the other exponent, which is 8 squared, which is also 64 minus 23. And then I'm going to do the middle one, because that's a multiplication. So this would be 64 plus 200 plus 64 minus 23. So 64 plus 200, the 264s add up to 128. So I'm going to do 200 plus 128. Now you notice that when you're adding and subtracting, it doesn't really matter what order you do them in. And then minus 23, I just did the 64s together because that's easier, and then I have 328 minus 23, and the final answer is 305. Okay? And that's it, and that covers Chapter 1, and we are done for today.